Okay. Hello, I'm Stephen Bremner, and I'm project manager of Team GoodBytes. And on behalf of GoodBytes, I have one request, or I guess one disclaimer rather. I'd just like to warn you guys if anybody's lactose intolerant in the audience, there might be a few cheesy jokes throughout the presentation. And then one request for the IAP judges, I just want you guys to sit back, hold on to your bacon, and listen to the recipe that was used to cook up GoodBytes. So again, I'm Stephen Bremner. I was sort of the project manager for a majority of the project after we sort of got everything under our feet and figured out what we wanted to do. I worked mostly, within the project, worked mostly with doing the database and server stuff, and I helped a little bit with the front end, basically just the communication between the server and database, and how all that protocol stuff was going to work out.
I'm Wesley Weaver, and I worked a lot with pulling data from the city, from reviews from the different restaurant recommendation systems that we pull data from, and I also worked with the search functionality of the website, and then a little bit with the sentiment analyzer.
I'm Jacob Peterson. I worked mostly on the front end and a little bit of the data collection that we did.
I'm Ryan Hansen. I worked on the timeline feature that we have, and also worked on geolocating restaurants.
I'm Charlie Yang. I worked with data collection from one of our sites, Urban Spoon, and I also worked on getting the sentiment analyzer to work with tweets.
And I'm Rachel Jaggers. I worked mainly on the Twitter analysis and mapping tweets to becoming restaurant reviews for our system. All right, so yeah, again, we're Team GoodBytes, and our slogan goodies from tweets. We actually had one of Rachel's friends help us out with making our logo, so shout out to that. And then, yeah, we're a temporal geographic restaurant recommendation system. And well, we started out sort of as, I guess sort of, our motivations were to just sort of do data analytics on social data and public data, but we didn't really know where we wanted to go with that. So we went back and forth for about the first, I don't know, almost a month of the semester, trying to figure out exactly how we were going to narrow this down. So we ended up narrowing it down into a restaurant recommendation system. And our motivations originally for the whole data analytics were to try to provide some sort of a good view of big data for companies to look at in order to sort of analyze their business and see different trends over time. So that's where we get our sort of business motivations. But then since we narrowed it down to the restaurant recommendation system, we also have a basic casual user that might come up and want to look, you know, where's a good place to eat? Or a traveler might come up and say, where's a good place to eat, sort of thing.
And we developed 5 use cases to kind of help frame exactly who our users are and what exactly they're expecting from our service. First, we had the average user, which is just simply a hungry person who has a computer and needs to find a restaurant to eat at. And secondly, we have the chef or the restaurant employee who wants to see exactly how does my service, my employment at a restaurant change the restaurant's performance overall. And we also have the manager who wants to see how does a new menu option, a new item, a new chef, how does that affect my restaurant's performance and what can I do to improve that? And then we have a more traditional approach of the tourist who is new to a city and is simply wanting a recommendation for a good restaurant to go to. And then finally, the corporate users who are wanting to see how restaurants are performing and potentially how they're going to perform in the future and then make business and corporate decisions based on that. And we have our hypotheses is kind of two-sided like the motivations. First, we have the user side, which is just simply a restaurant recommendation system that seeks to pull social media data, aggregate that, analyze it, and then display it in a visualization that is unique to our application. And then to also display some general restaurant information to the users, like website address, a Google Maps link, so that they can better find the restaurant and better visit it. And then finally, the corporate side of our hypotheses is that it is a tool for corporate management to use, and it's going to provide them with a unique view of restaurant performance, and then also an avenue for them to gain insight into maybe restaurant performance trends and restaurant performance predictions.
So when we were developing this project, we wanted to be aware of all possible concerns about ethical implications, and one of them was that low ratings could affect some restaurants. You know, this could be a negative aspect for a lot of restaurants, especially for ones that only have a few ratings and they end up being negative. And so, but in order for this to be an accurate review website and for us to provide equal access, we have to allow it to be open to everyone. And so, we allow those negative reviews to stay in there, but we also allow ourselves to be open to contact via email from the restaurant owners to contact us if they want to take down their website or their restaurant from our website. And the next one is that we could potentially promote unhealthy eating. We don't directly promote unhealthy eating in any way, or we don't even promote websites that could possibly provide unhealthy food. We're simply an open website for information and that allows users to review all the ratings and reviews themselves and make that decision based on other restaurant reviews by restaurant patrons. And the last one was data security issues. Because we gather a lot of this data from Twitter and other social media sites and from review websites, people can be concerned whether their identity or their information is being used by some random person on the internet. And so, but because we are gathering these from social media websites and review websites, we're only accessing stuff that's publicly available to anyone with internet access. And so, anyone with even a mobile phone can access this data. And so we actually store, in our database, we store less information than what Twitter and Urban Spoon would provide to anyone else. We don't store any kind of reference to the identity of the person who posted it.
So prior work is obviously any restaurant recommendation service like Urban Spoon, Yelp, or Zagana. And then also social media analysis. It's an emerging field. A lot of companies use it for brand management. Then you have companies like Engager and Social Sprout who made a whole business out of social media analysis and the insights they can get from it. For our design, it's a .NET MVC3 web application. Uses HighCharge.js to do our timeline functionality, which shows the restaurant's rating over time. And then uses Twitter Bootstrap like every other website should. And Font Awesome, which is just kind of icon set for Bootstrap. And also some Google Maps. Then our backend is all on Windows 2008 server. Our data is in the SQL server. And then we also have a search functionality. It's done using TF-IDF. So for the implementation, we got most of our tweets from Dr. Caverly's InfoLab. They provided us with this data set that spanned over 5 years of geolocated tweets from Houston. We used the Senti Strength sentiment analyzer to analyze the tweets that we had. And then we worked with Dr. Goldberg, who helped us on kind of the geolocating aspect of it. And then we got other reviews from CityGrid, which is a system that provides you with reviews from like Urban Spoon and Yelp, I believe, and Foursquare. And then Charlie crawled Urban Spoon to give us some other reviews.
And so to conduct our user studies, we ask people to visit our website and then take 2 surveys based on their experience. The first survey was about the usability of the project and how easy it was to use. Overall, we received a lot of positive feedback. Received mostly overwhelming positive feedback about browsing the website and being able to browse restaurants. We also accepted some suggestions on improving the search function. And then the second evaluation was about the usefulness of the project and what kind of value it added to a person who's looking to eat at a restaurant. We received a lot of overall positive feedback from it, especially when it came to our timeline feature and the ability to browse restaurants by food category and cuisine.
So these are the final numbers that we ended up coming out with. We started out with 11 million tweets from Dr. Caverly's lab. And what we did was we needed a mechanism for mapping these geolocated tweets to each individual restaurant. So the first thing we did was we used geolocation We used Google Maps API we had 785 restaurants. And we did the nearest, a surrounding box around each restaurant and tried to map each tweet to within that restaurant if that was going to be our first step in towards coming out with relevant tweets. The second step was we needed to figure out, there's a lot of garbage with Twitter. A lot of people tweet things that are not even relevant to restaurants or anything. So we needed a way to figure out if the user was tweeting about that restaurant. So we used 1,000 tweets for a classifier to train on, and we used 2,000 to test on. And our classifier came back with about a 77% accuracy in classifying a tweet as a review. And as you can see, we have, out of the entire 11 million tweets that we collected, only about 180,000 were classified as relevant. So if you go on to the next slide, that comes out to a ratio of about 91 to 9 of restaurant reviews that came from Twitter and restaurant reviews that came from CityGrid and our Urban Spoon. That's kind of what we wanted. We wanted more social media driven restaurant review recommendation because we felt like more people are relevant and more honest on social media. So we were trying to get this new aspect that maybe wasn't seen before in user defined reviews on these other websites.
So the benefit of our system to users and restaurant goers is that it's primarily the timeline, which offers them a visual view of how restaurants trend in terms of sentiment. So restaurant goers can track their favorite restaurants over a long time period and see how well their restaurants do. Go to the next slide. That's the same for restaurant owners who can also see how well their customers think of their restaurant in a very intuitive manner with the timeline over time period. Go to the next slide. So it is our hope that restaurant owners can predict how well their restaurants will do in the short term with the timeline. Of course, for our future work, we would like to improve the accuracy of our system, which relies heavily on data sources like Twitter and Urban Spoon, Zagat, and primarily what we would like to improve is the size of our data set, which given increased data should provide a smoother trend line and a more accurate gauge of overall sentiment about restaurants. And certainly that relates to sentiment analysis. What we used for sentiment analysis, Senti strength, is specialized for short length messages like tweets. But we would like to train that for on restaurant reviews. So that would perform better for tweets which we currently do not recognize as relevant reviews. And the third point, dynamic data, is that we would like to refresh our data set continuously. So as reviews get published on our data sources and Twitter, we would like to update our website to reflect those changes and update our trend line more dynamically now.
And then one last final point on the future works. So one of the things about our product right now is that it's very heavily geared, I suppose, more towards the user end of our hypothesis as opposed to the corporate end. And part of that has just been difficulties with getting things to work and sorting out bugs and all kinds of random issues that pop up in the development process. However, one step that we would like to take towards the corporation side of things for future works would be to sort of, lost my train of thought. So in order to progress towards the corporate side of things, we want to be able to do something called anomaly detection, which is sort of a extended feature that we discussed at the very beginning of this project. And what this anomaly detection would be is we would take a look at also current news articles and sites and stuff like that. So we would look at maybe New York Times and see these recently posted news items and see if we can tie these, if there's say a major event like a football game or something going on the weekend, maybe that's better for businesses, and we can see these trends in our timeline. And the corporate businesses can look at this and maybe better gauge how they want to put out their employees or
if they want to try to like maybe advertise their product better for those types of events, or if they want to maybe, 50-cent beers or something on Saturday because of the football game. It'll get a bunch of people to come in, and if you're drinking beer, you're probably going to be eating a burger or whatever. So yeah, so that would be sort of to try to push us more towards the corporate end. So yeah, in conclusion, we've stumbled a couple times, but we're towards the finish line for our project. We've got a beta test of our product out there. We've still got another week to finish up our project here for at least for the letter grade part of it. So yeah, we're pushing for that final week. We want to try to improve some accuracy. Maybe if we can mop up a couple of our future works sessions, or maybe get beta tests of those out even. But yeah, so.
Now time for a quick demo. Allow some time for questions. So this is our home page, and like most websites, we've got a contact page. It allows you to contact us, and then shows our Twitter feed and our Google Plus feed. And the About Us it gives a couple sentences about each team member, gives their names, and then the How It Works section kind of describes each main part of the project and how each one of those works. And so currently we're only serving Houston, Texas, but in the future we're going to hopefully expand that. So you can see all the categories and cuisines of the restaurants, and let's search for one first.
Can you do it on Google Chrome?
Oh, am I in your next door? Okay.
So yeah, I guess one of the limitations, while he pulls it up on Google Chrome here, is that we did use a lot of newer features. So we used a lot of newer Bootstrap features as well as HTML5 features. So we do have some, it'll function on other browsers just fine, but the features won't look as pretty. So we'd at least like to demo the website with the most beautiful looking section. And of course, with if anybody, I'm sure a lot of people here have done web development. So yeah, with web development, there are a lot of issues with Internet Explorer.
Okay, so let's search for a restaurant. Uchi, I've never been there, but Jake Peterson says it's delicious, so. So first you can see the Google Street View of the restaurant, and then that's going to link to that in a new tab if you want to click on that, and the Google Maps as well, so you can find it, and then a little bit of basic restaurant information. So here is our timeline. So you can see that we have data from April 11th to October 12th here, and you can see exactly what the rating is on each day, and then you can zoom in further and say, okay, if we want to see July 11th to January 12th, see that further, zoom in, and then see exactly what the ratings were.
So one thing I'd like to point out about our timeline, so what makes the timeline a little bit unique as opposed to the actual rating that you see at the very top of the page, is that our timeline takes the 30 days most recent to that date and computes an average over those 30 days, and that's how we get our bullet point, as opposed to just averaging all the tweets from the beginning of time. Otherwise, because if we do that, then a single review won't have that big of an impact on the data. So we want to take a smaller set and try to get that sort of
so each point is the past 30 days?
Yeah, each point is 30 days before it.
And then you can also find a restaurant by category cuisine. So let's do pizza, and then Indian pizza. Let's try that.
Some Bombay pizza.
So there's the timeline. And then we also show the most recent reviews. So we can see 3 recent reviews here about Bombay pizza. And then the 3 most positive reviews we have. And then the 3 most negative reviews we have about this restaurant. And then we also allow a user to add a review so that we could continue to expand our data set. Any questions?
So did you guys write the Twitter classifier, and what attributes do you extract?
So I wrote it myself. I at first tried to use some existing ones from NLTK, and I was getting nowhere above about 30% accuracy, and that's really difficult. We needed better than that. I couldn't have 70% garbage being put into our database for the reviews. So I wrote my own, and it came out with a 73% accuracy, and I tweaked it a little bit to do some keyword recognition. Words like restaurant, words like eat, I wanted those to be automatically classified as a review. But I wrote my own to short answer that.
How do you determine the accuracy?
The accuracy? So I took,
Yeah.
right, so I took 2,000 tweets that we all humanly labeled and ran the classifier on it and came back with 77% accuracy. So we hand labeled 2000 tweets.
So how do you guys remove like the owner reviews?
How do we remove the owner review? Yeah, I guess that's sort of a small flaw.
Or the competitor reviews?
Yeah, competitor.
We're trusting in human morality.
Well,
No
yeah.
one
Yeah.
We think that everybody thinks that Bombay Pizza Company is a 2-star, so we think that they'll be, uphold their end of the integrity bargain. So. I mean, we can't deal with that, and it's really hard for any site for that matter to deal with that. So it's a problem you run into with a user-driven application.
Well, statistically, if you have more than one review, you can average it.
Yes.
How did you approach designing the website, and what to show, how to do the search, how to navigate between things?
Would you like to answer that, Dean?
I mean, just kind of looked at other sites and how they did things. Just threw things out there until it looked right.
We went through several phases with it, really. So, for the most part, the general UI has sort of been there the whole time. But improving navigation, adding features like the sort by up here and stuff like that, those are sort of features that we added along the way that we thought would help the user navigate better. They have like you shouldn't have to click more than twice to get somewhere or something. So we tried to semi-follow that as best as we could. But it's hard to take so much data and put it in a way that you can access it all really easily, So sometimes we had to buy like, 2 clicks, sometimes 3 clicks or so. Is it scalable? Yeah, you can do it on your mobile device. It's yeah, it's not exactly.
It uses Bootstrap, which is
It's a lot of data
a little
display,
bit,
though.
but it's a lot of data, and we didn't add any mobile views to it, so it's not specialized for it. And the stars screw up on the mobile device. I'm not gonna lie.
I will pull it up.
I mean, you can look.
So you mentioned leveraging big data principles. What are some of those technologies that you guys use in analyzing the data?
Do you want to?
For majority of it, we use Amazon. Amazon has a web service, and you can run EC2 instances. I used, I think, like 30 gigs RAM. I souped up a box and ran, because 11 million tweets is a lot of text analysis. So I was using Amazon mainly as my way of analyzing this in a shorter time frame on my little computer with 2 gigs RAM. It was not, it was going to take days to analyze, so.
And to analyze the sentiment of the tweets, we used a service out there that's called CentiStream, and it takes into account the language inquiry word count dictionary, which has like, I think it's 11,000 words, a lot of words that they have different sentiment values with, and then you just simply feed it a file.
Into a sentiment score.
Right, exactly.
The Loop dictionary is like maps of different psychological values for every word, and then it computes sentiment based off of those values.
So if you, I'm sorry, if you're going to commercialize this, what type of architecture would you use to handle the dynamic data constantly coming in and constantly analyzing the data?
So if we were going to commercialize this and wanted to import data dynamically like that, we'd probably want a dedicated server for that because we wouldn't want to bog down the user experience. So we'd have a dedicated server which would be doing these web crawls or such to try to pull the data from these public sources, and then we would use that to upload it to our primary database. And then the server would just work as it normally would, and all the functionality would just automatically populate as the dedicated server would upload.
And you'd use the Twitter streaming API to stream the tweets in, and then the CityGrid API you can stream as well to get the reviews in, so we could pull the data in like that. We just have to have a lot of money to pay for a subscription so that they won't limit our data streams.
What type of database are you using for your primary database?
It's a SQL server.
SQL server?
Yep, 2008.
Something interesting to point on that though too, so our data set is actually very, very small. Geolocated tweets are tweets that your mobile phone had the device on, the location setting on, and that's only about 2% of all tweets. So our server would be storing so many tweets and we only need about 2% of those.
Okay.
Yeah, to address that issue again, that would be exactly why we want that dedicated server, because there will be a lot of computation to weed out all the garbage, basically.
And that's why we chose not to do that
Yeah.
for this project.
Have you guys considered Hadoop?
We have we have one of these running upstairs,
Uh-huh.
and that's our server. So it was kind of out of the question.
Yeah.
Right, with unlimited money and time, you can do anything, right?
Okay, all right.
Did you guys find anything interesting with the time data?
I'm sorry, one more time?
Anything interesting or funny that you found looking at the time as far as the center tracker?
Interesting or funny in terms of the time. I mean, we saw some rather interesting tweets, which we retweeted a couple of them.
If
If
you
you
follow
want
us
good or about us.
about us,
I guess I'm curious, did you see anything did your sentiment timeline correlate to
Are these-
anything interesting in terms of like an owner may want to use?
We have a lot of data. So searching through all these restaurants, I mean, we probably browse through about 50 restaurants or so, trying to find various different things. And I mean, there would be hills and valleys, but again, a lot of it comes down to the fact that we don't have a whole lot of the data right now. So we had 11 million tweets, and we filtered that down to like 179.3 thousand or something like that. So our data set's a little bit limited to try to identify like obvious trends. We could see trends, but you can only wonder whether or not, whether they really are. So again, that would be something that we look into in the future. Maybe that would be something where we could see, did they get a new chef in their restaurant? Was there a major event that happened in that city? You know, maybe a hurricane came through or something, and obviously they're not going to have much business then. So.
I have to say what we were laughing over. He read that first tweet to me and we were laughing, so we weren't laughing at you guys. Just wanted to let you know.
Oh, no, that's fine, yeah. So these retweeted tweets were part of the data set that we manually went through, so obviously that one wasn't to review.
Cool.
Any more questions?
Any more questions, anyone? Cool. Let's give them an applause. Great job. Cool.